So for this one, we're just going to do the same thing. We've been given the series. This one, I don't know exactly what series this one's for, but we're going to do the interval of convergence. So we're going to do our ratio test to start. So limit as n goes to infinity. Okay, it's going to be x plus 4. So the center is at negative 4. X plus 1. N plus 1. And 3n plus 1. Okay, and then the other term is going to be just to the power n. Okay, so there's my ratio test. I'm going to do my simplification now. I'm going to group my terms. So the limit as n goes to infinity. The x terms, I'm just going to end up with x plus 4, just one of those. The n terms, so I'm going to maybe do this in a different color here because I've got a few things now I have to group. I've got n over n plus 1 for my n terms. Okay, so that's going to be n plus 1. Those are going to be my n terms, and my power 3 terms, I'm going to do it in a different color as well. My power 3 terms is going to be 3n over 3n plus 1. That has to be less than 1. So as n goes to infinity, that's going to be equal to 1. The n's cancel out. Maybe I'll just show the extra step here. Limit as n approaches infinity. This is going to be x plus 4. And again, this is going to reduce to 1. N over n plus 1. And then the x terms are going to simplify to 1 over 3. Okay, so then I can now apply my limit. So I end up with x plus 4 times 1/3 is less than 1. Moving that term over to the other side, I end up with x plus 4 is less than 3. So the center of my convergence is going to be at negative 4. Looks like my radius is 3. So then my interval looks like this so far. So I'm going to be at negative 4 minus 3, negative 4 plus 3. So that's going to be my interval so far, which now I have to test. Okay, so then I'm going to test this interval. So I'm going to test negative 7. X equals negative 7. So when I plug that in, my sigma looks like this. So I'm going to end up with negative 3 to the power n over n 3 to the power n. So this is going to simplify basically to negative 1 to the power n. So makes this an alternating harmonic series. Okay, so n equals 0 to infinity. This is going to be negative 1 to the n over n when I simplify that exponential out. This is convergent. Okay, so that means that endpoint, since I tested that endpoint, I'm going to include that endpoint as part of my interval. Okay, then I go and test the other endpoint. X equals negative 1, plugging that in, n equals 0 to infinity. So I end up with negative 1 plus 4. Okay, so negative 1 plus 4 is 3 to the power n over n 3 to the power n. Those 3 to the power n's are going to cancel out. And we're going to end up with just a harmonic series, which is divergent. N equals 0 to infinity, 1 over n, This is divergent. Okay, so then that endpoint we're going to not include as part of our interval. Okay, so then our interval is going to be, our interval of convergence is going to be this one here. Okay, so our interval of convergence works out to be from -7, including -7, and -1, not including -1, so it's a half open interval. So the last one here, we're given the series. We don't need to generate a Taylor series or anything like that. We've been given the sigma notation for this. So the hard ones would be if you had to generate the series and then come up with a sigma notation. That can sometimes be a challenge. Some of them are easy, some of them are more challenging. But once we have this sigma notation, we can test the convergence using our ratio test. So limit as n goes to infinity, x to the n plus 1 over square root of n plus 1 all over x to the n all over root n. Okay, so I want to know where that is equal to, is less than 1. So then rearranging that, grouping my terms, I'm going to let n go to infinity. Grouping my x terms, I'm just going to be left with x. Grouping my n terms, I'm going to end up with square root n over square root n plus 1. Okay, so there's my ratio test. Now this ratio, when I let n go to infinity, square root n over square root n plus 1 is going to be equal to 1. So then I apply my limit. My center is at 0, my radius is 1. So my interval is going to be from -1 to 1. Test my endpoints. When I test the endpoints, this is what my series looks like. When I plug in my -1, I end up with -1 to the n over root n. This is an alternating series that converges to 0. Well, using the alternating series convergence theorem, this one converges. Okay, so then I include that endpoint. That -1 is a closed endpoint. I include the -1 as part of my interval. So then I'm going to test x equals +1. When I do that, this time I'm going to end up with a diverging series because I end up with a harmonic series that doesn't alternate, that diverges. Okay, so that one, I'm not going to include that endpoint. So that endpoint is open. Okay, so this is my interval of convergence, half open. So I have a half open interval of convergence. Okay, so there we have it.